Welcome to a new video for Algebra 2. In this video we're going to be exploring ellipses. So an ellipsis is essentially a circle but that's elongated. It's elongated either via the x-axis like this one right here, okay, or it can be elongated via the y-axis or the vertical. Let me show that right there. Okay. So take notice up here real quick. This is the standard equation for an ellipsis that has a center other than 0, 0. Because if this was 0, if this was the actual center, then h and k would be 0, and then you'd just be looking at x squared plus y squared. Okay. So for this particular ellipsis, its center is 0, 0. Okay, I'll manipulate this. I'll move this around in just a bit. But first, what I'd like to do is I'd like to explain just some basics for the ellipses. So the ellipsis has essentially two axes of symmetry. It has an axis of symmetry along the x-axis and along the y-axis. Depending on the conformation, the way the ellipsis is situated, the longest end will be the major axis. In this case, your x-axis will be the major one. And then your minor axis would be the shorter side of the ellipses. Okay, so this long side here, their major axis, I'm highlighting it in red. This point would be A0. Okay, and then this point over here, go ahead and highlight it in blue, would be 0B. Okay, and that's this one right here. Okay, so the end points of each of these are your vertices. So this is your vertices along the major axis, and then this is your co-vertices on the minor axis. Okay, so again, this length here, this length B, coincides with the B that the y coordinate is at this point. Okay, and that actually coordinates or goes with this B right here. Okay, and then the A, the length of A right here coincides with this aspect of the equation. Okay. Now there's also another point here that isn't shown, and that is what's called the focus. Okay, this is the focus. So the focus for this conformation, this type of ellipses, will be C0 because there's no y. It's on the x-axis right here directly. So it's C0. Now, this is important because just in case, when you're given an ellipsis, just in case you're not given this particular point right here, this C, this focus, is important because when you draw a line from this C, the focus, to your B, this hypotenuse is the same length as your major axis, from your center point to the major axis. So this A is equivalent to the hypotenuse, the line that is made from your focus to your minor axis vertices. Okay, so that's important. So again, depending on the situation, you might be given a coordinate point here. So if that's the case, then you won't really need this necessarily. Or you may not be given this point over here, this major axis. So by using your focus, you can use Pythagorean theorem. You can use the distance formula to find the distance between the focus and your minor vertices to find the length of A, okay, which will give you this particular term right here, okay? Okay, so now that you see, I've cleaned up the board here. I've got nothing going on. Now I want you to take a look at how manipulating the different variables affects your ellipses. So again, this is your basic, let me highlight this real quick. This is your basic formula. This is your basic formula for your ellipses right here. Okay? So now let's play around with this so we can see what happens. Now notice again your A. Your A is your major axis, so look what happens when I manipulate your A. So as I increase A, it elongates further along the x-axis. Okay, now also pay attention because as I manipulate this, look at this term right here. This is the term that's being manipulated. Look at my x-axis. Does it increase? Okay, now as I go down, look what happens to that major axis. It shrinks, okay, making it shorter. It's still an ellipsis because it's an uneven shape. But then when I reach 2, notice now that it's 2, now it's actually a perfect square. So that's not an ellipsis. You want an ellipsis that has different lengths. You have a major axis and a longer axis. Okay. All right. So now let's take a look at what happens when I manipulate my b term. Okay, which is this term right here. Look at what happens. Here's my b. I'm going to change it up. So I elongate it along the y-axis. Okay, so now that my y-axis is actually longer, I have gone from a horizontal ellipsis to a vertical ellipsis because now my major axis is along the y-axis. Okay, that's my major axis now. In fact, let's spend a little time with that. So let me make it a little bit more obvious that it's a vertical axis or a vertical ellipsis. So now that this is my vertical ellipsis, now my major axis is right here. So this is now my 0, A. So that's length. This length is A now. Okay, and then my B, this is B0 now. So my B term, this B term is referring to my minor axis. And then my focus. So my focus is always going to go along my major axis. So you notice that the minor axis doesn't have a focus. So this always goes on the major. So recall that. So this one is 0C. When my focus was on the x-axis, it was C0 because C was my x term. In this case, I'm right along the y-axis, so I have no x term. That's why it's 0. And recall that if I'm not given the length of A, I can make a line using distance formula from my focus to my minor axis, and this hypotenuse, this line, will give me the length of A itself. Okay, so recall that. Now, something that didn't show when I did it here, I'm gonna go to a vertical ellipsis. Notice what happens to my equation here. When I go to a vertical ellipsis, look, now my y term is in the front. My y term's in the front, and then now it's A. My A is now, actually here, this is technically not showing a vertical ellipsis. I need to shrink. So here, you'll notice that my A term is the y-axis. Whereas before on the horizontal ellipsis, my A was on the x-axis. So as I increase A, which is right underneath my y, that it increases along the y-axis, and then along the b-axis, my minor ellipsis is on the x-axis now. Okay. All right. Now let's see what happens when we change our h. Let me erase what's going on here. Look what happens when I change my h. Okay. So the h, manipulating the h, moves the ellipsis along the x-axis. Right. And then manipulating my k, just like with my previous equations, I'm able to translate it along the y-axis. Right? Okay, so I hope the basics here for an ellipsis helps, and I'll work out some practice problems from the book next. Okay, good luck in your study.